In this video, we'll be learning about tabular integration. Now, the questions that we solve using integration by parts can also be done using tabular integration, but in a faster and easier way. However, there is one small limitation to tabular integration. Tabular integration does not work with logarithmic functions. So if we have something like x ln x or just ln x, we cannot apply tabular integration. In those cases, we must use regular integration by parts. But for most cases, especially when we have to use integration by parts more than once, tabular integration can really save time and effort. Now, let's understand the tabular integration and how it works. We will look at three types of combinations here: algebraic and exponential, algebraic and trigonometric, and exponential and trigonometric. Let's start with the first case. We have an algebraic function, x squared, and an exponential function, e power x, and we need to integrate it. According to Liège rule, we take the algebraic part as x squared, as u, and the exponential part as v. So let's build our tabular columns. On the left, we will be building a column of derivatives of u, and on the right, we're going to be building a column for integrals of v. Now, in the first row, we're going to be writing the values of u and v as it is. So x squared here and e power x here. Now we're going to be taking the derivatives of u till it becomes 0. So for the second row, it's going to be 2x, then 2, and then 0. Whilst for the integrals of v, we're going to do e power x, and e power x, till the row reaches the row of 0. Now, we're going to connect each derivative with its corresponding integral diagonally, like this. And then we're going to be applying the signs here, starting with plus. So first one, it is going to be plus, then negative, and then plus. And in the final answer, we're going to be writing them as a product. So it's going to be x squared e power x minus 2x times e power x plus 2 e power x plus c. And that's how you do tabular integration. Now let's take a look at this example. We want to find the integration of x cubed sine of x using tabular integration. So our algebraic function is going to be x cubed, so you will set it as u, while the trigonometric function is sine of x, so it becomes v. So the column for the derivatives of u is going to go like this. First, we are going to write u as it is, x cubed, and then we're going to take its derivatives till it becomes 0. So 3x squared, then 6x, then 6, and finally 0. For the integrals of v, we're going to write sine as it is. So the integration of sine becomes minus cos of x. Integration of minus cos of x becomes minus sine of x. And then it becomes cos of x and sine of x. Now we connect the derivatives and integrals diagonally, starting with the positive side. So this becomes positive, negative, positive, negative. Now we're going to put everything together and write the final answer like this. Now let's move on to exponential and trigonometric functions. We need to find the integral of this function. This type of integration becomes lengthy, with repeated integration by parts, like we did in the previous video. So we'll use a tabular method here. In exponential trigonometric combinations, it doesn't matter whether you choose e power 2x, an exponential function as u, or a trigonometric function cos of x as u. So let's assume that u is equal to e power 2x. Hence, v becomes cos of x. Now, we'll be differentiating u and integrating v repeatedly. We are going to build a table where we differentiate u and integrate v until both parts repeat. Our focus is going to be on the functions themselves, and we'll be ignoring any changes that come with them, such as negative signs or the coefficients. So let's start building the table. First, we're going to be writing the values of u and v as they are. So you have e power 2x here and cos of x here. Then you're going to take the first derivative of u, which is going to be giving us 2 e power 2x, and the integral of cos becomes sine. Now we can see that we have e power 2x and sine of x. We'll have to take one more derivative and one more integral because this row still doesn't match the first row of the table. Then taking the derivative becomes 4 e power 2x, and the integral of sine becomes minus cos. Now, ignoring the coefficients and the signs again, you can notice that we have e power 2x here and cos of x here, which matches the function in the first row. So we're going to stop the differentiation and integration here. Just like before, we connect diagonally and with alternating signs. So this one's with a positive, this one's with a negative, and there is a twist here. This one's going to be a horizontal arrow, like this, with a positive sign. In a moment, we're going to see how I'm going to be writing this part here. So let's rewrite our integral. Integral e power 2x cos of x with respect to x equals e power 2x sine of x plus 2e power 2x cos of x minus 4 integral e power 2x cos of x with respect to x. Notice that this one is still being integrated, and it is exactly the same as the expression written on the left-hand side. So now we are going to simplify this by taking it to the left-hand side. This becomes 5 integral e power 2x cos of x with respect to x is equal to the same thing. Now, we're going to be making this integral the subject of the equation by taking 5 to the right-hand side. So our final answer is going to become this. This is how we integrate a product of exponential and trigonometric functions using tabular method plus algebra. It saves time compared to the repeating the integration by parts twice.